recording. And so tomorrow we'll be going over 3.2, which covers unit testing in Android Studio. There's actually two different lessons related to automated testing in this particular course. We won't have a whole lot of time to hit all of that, partly because it's kind of a deeper topic. It's something that, automated testing is something that's really, really great when you're working with production applications and you need to be able to quickly test and find bugs. So there's kind of two ways to test it. One is to kind of test your back-end logic without the front end, and so that's kind of what we get into in 3.2, and we'll look at that tomorrow. And then later on, lesson 6.1 covers how to do UI testing with something called Espresso. And that gives you a lot more automated functionality using Espresso than you can do with just straight up unit tests. Unfortunately, kind of time limiting, and because that doesn't fit in with, it doesn't really fit in with the rest of the curriculum. We won't be going over lesson 6 is my plan. My plan is to skip that. So fair forewarning there, which means that in the end that we're not going to go very deeply into unit tests this semester. Just because it's a much more advanced topic than we really have time to cover. So we'll do some labs with it, but it's not going to be something that we have a chance to kind of do on every assignment. So you'll see that here and then probably not again after this week, just as it happens. Okay.
Yeah, I was noticing in the schedule that after spring break, all the days are empty. There's not, I think just Picasso and Volley are in there, and then that's it. Is that to be determined depending on our
in perusal? Yeah.
No, I'm looking at a Google sheet.
Oh, you're looking at the schedule?
Yeah, that's what I meant. Yeah.
Okay. Mm-hmm. So yeah, at the schedule, and you were looking in where?
Okay. Well, I can post the link in the room.
Yes, yeah, there it is. I see it. So I've got it open. April, and you're talking about April and then through May when the semester is. Yeah. So the plan is to finish up this part of this Google course at the end of, we're going to finish it up in March before spring break. So after spring break, there's some topics that I'll bring in, which are third-party libraries. One of those is Picasso. Another one is Volley. There's a third one that I haven't really put the specs in, but is a way to connect to it's a Square API that they've made, and it allows you to connect to REST APIs, so you can integrate a REST API with your Node apps. So we'll kind of talk about that here, as well as getting into Firebase. So that's where we'll be. April is we'll be doing some stuff that's not in this text. Does that make sense?
You said Node? Did you say Node on purpose? That's what we'll be using?
So that's where we would connect to Node, right? So what we're looking at in April is connecting back to what we did in third semester. Okay.
Whoa-wee. Okay.
Unfortunately, that actually is in my mind is the most important thing, to say take your Android application and connect it with a web application. Unfortunately, I have yet to find a course that actually incorporates that as part of their curriculum, which is really odd to me, but it is what it is. So that's why we're kind of maybe pushing through some of this stuff. If the pace seems high, it's because I really want to make sure that we have some time to do that. Because, and that's where I might sacrifice some of the lessons here to try and, make room for that, if that makes sense.
Yeah, right. What's the fair and full warning for what we're learning here in 3? Is it pretty simple? Is this light material?
For lesson 3, yeah, lesson 3 is super easy. So kind of going back to where we're at. So automated testing is kind of, you'll get an intro to that on Tuesday, but and we'll do. I've got a worksheet we'll work through for that. So I've got some assignments there that you can build unit tests for. And 3.3 talks about the support library, which has to do with supporting older versions of Android, potentially all the way down to like 2.0, Android 2.0 or so. This one has, lesson 3.3 has not aged well. There's a lot of things that have shifted, and in Jetpack, the things that were in lesson 3.3, they've moved from the old support libraries to, they're now under the Jetpack umbrella. So that's a really important thing in the world of modern app development now, is to understand and use Jetpack. So those support libraries used to be under the libraries in 3.3 used to be under one kind of umbrella, and there were certain things you needed to understand. And a lot of those things, some of those things have changed and aren't really relevant anymore. The other part of the labs that they give you in 3.3, they're not really related to real world development now, because basically what they get into is issues that we had before 5.0. So, a lot of things on that front have shifted. Will you be using the support libraries? Yes. But because of things having shifted, I'm ditching the lab assignment, the lab component for 3.3. So that's part of the kind of the schedule this week. So also kind of, I looked at the code labs between 3.1, 3.2, 3.3, and kind of looking at what you were going to learn from those, and decided that they really didn't make sense to give as an assignment. So rather than do the code labs this week, I've got my own worksheet I'm going to give you. Okay?
Right.
So it's already up on inside Ranken, under lesson 3. So you'll find it. Let me get in and go to the coursework view here. So I'm back in here as the student view. So you'll see that there's a lesson 3 worksheets assignment. Underneath there, you'll find that it's graded on. There's 3 projects in there. There's a sum project, some product project, prime numbers, money tracker. So there's 3 apps that you're going to be building for this, and so basically I've put up the 3.1 version of this. Tomorrow I'll put up the 3.2, which adds the details about the unit tests to do with those. So these are the projects for this week. Rather than doing the code labs, this is what you're going to do, and they're based on some of the assignments I gave you for the console applications. So they're kind of modified from there, at least some of them. So in that worksheet, if you pull it up, you'll see that there's first listed up guessing game. So we're going to go through that one together as a practical example. So because the practical example that I think you really need a larger practical example to kind of understand the stuff in lesson 3. So we're going to do that one together as an example. Then you'll have some product, prime numbers, and money tracker. You'll notice that the money tracker is the larger amount of that points. So 20, 20, and 60, because it is a larger thing I'm asking you to do. Okay. Does that help kind of understand where the labs are this week?
So how does this work then? Do we get one project per day? or do we have to work on all three every day?
You can work through those three this week, right? So they're due. Those three projects, the finished versions are due on Friday.
But you said we're getting part 2 tomorrow?
Yeah, I'll give you some addition to it. I just didn't have time to sort out the unit testing stuff for all this today. So.
Okay. So there's only 2 parts.
It's only 2 parts. And so I'm just giving you this part today, and I'll give you the rest of it tomorrow. And so it's the same projects. Does that make sense?
Yeah, I just didn't know if like we were getting half of the project today, the other half tomorrow, and then we get the other days to work on it,
Yeah, that's basically it. You're getting half of the requirements today, and I'll give you the other half tomorrow. And so yeah, then it's just due by Friday. So I was trying to look and see and trying to get all this sorted out and put on one sheet this morning, but I didn't quite get to it, which is why I'm kind of like splitting it up. So that's the lab assignment. So we're clear on that. So the guessing game is not for grade, but the other three are. Okay. So on Discord, I've kind of posted the agenda for today. So we're going to go over 3.1, the concepts, and I'm actually going to look at the chapter instead of the slides, because they are kind of arranged a little bit differently. So I'm gonna focus there, and we'll kind of, as we work through that, I want to pull up the Simple Calc demo application, so we can kind of see where things are in Android Studio as we're kind of looking through that. So 3.1 is basically just here's how you use Android Studio is kind of the gist of it. So there's no new coding concepts really in 3.1. It's just really how to use the debugger. So anyway, if you would go ahead and pull down that Simple Calc. I put it up there on Discord as simplecalc.zip. Please pull that down and toss that into your 3.1 folder, and we'll kind of go through it. So pull it down, put it in Android Studio. So thumbs up the post when you have the Simple Calc project pulled up. and it's running a little bit late here on kind of getting going, so we're probably going to take a break at probably closer to 2-ish today. This will probably be our first break. Okay. All right. So let's kind of talk about 3.1 is really about the Android Studio debugger. And realistically, you whatever programming language you came from, we've done JavaScript last semester. You did C# in your second semester, and we did maybe a little bit of JavaScript in your first semester. Every IDE that you work with, or any language you work with, at some point you'll need to get into and use the debugger for that particular language or platform to kind of figure out what's going on with your code. So Android Studio includes one of those, and it will let you debug code that's actually running on a physical device if you have it plugged in, or an emulator. The big one that's really kind of interesting is that idea that you can push it to a physical device and have it kind of pause, because that's kind of a non-trivial thing to do, but it works, so you can. So the tools that are there are very similar to what you've seen in any IDE, similar to Visual Studio, where you can kind of set breakpoints and step through your code line by line and see what's going on. So all our focus on today is to just kind of talk about maybe a little bit about why you want to do that, and then where all those buttons and things are in Android Studio. Okay. So let's kind of talk about, what is debugging. So debugging in general is the process of finding and fixing errors, also known as bugs, or unexpected behavior in your code. And in reality, all code does have bugs, whether it be incorrect behavior, whether it be using too much memory, using network resources. It may be freezing, crashing, maybe it produces the wrong results with user input, maybe it fails to save. There's a lot of different things that can be problems in your code. So that's kind of that's part of the topic for this week, is to kind of look at that and figure out learn some tools that you might use to resolve those bugs when they occur and when they're present. Okay. So those bugs can come from a lot of different places. They might be errors that you've introduced in the way you design the application, or in ways that you implement it. Maybe the way you designed it doesn't really conform with the Android spec, or you didn't really pay attention to the lifecycle methods. So you're not hooking into like the on start and the on stop and on pause, on resume the right way. So you're kind of getting bugs there. But it also could just be that your calculations are off. So, maybe when you put in 10, you're supposed to get out, 50, and you're getting out 60. So that might be a logic error there too. Sometimes it will result in a crash. So, you think maybe you expected the user to just enter numbers and they entered letters instead. So that would be another thing that you might need to debug and fix. It can be other things where, we ran into issues with permissions on Friday because of compatibility things. So there may be changes that are and bugs that happen there just because they're, maybe they're running the application on a device you didn't test with, right? So maybe you tested your application on, Android 10 and Android 5, but you didn't test it on 6, 7, 8, 9, or 11, right? So it might be that it works on those two versions that you tested, but doesn't work on any other. Also, I've seen this happen before. You tested on a Samsung device, and then it doesn't work on a Nexus device, doesn't work on one of the Google devices, and vice versa. There are some differences between different device manufacturers still, even though there really shouldn't be. There's not supposed to be. But there are differences in way that Samsung builds things, and sometimes even there are differences in different versions of Samsung devices. When I was working in the industry, we were using the Samsung Tab 3s for the project that we were doing in pretty heavily, but as it turned out, Samsung made a lot of different versions, a lot of different builds of the Samsung Tab 3, which as it turned out didn't work the same way. So even though they were technically on the outside the same model number and they looked similar, I would see different behavior from device A to device B because underneath the surface there were software differences between the two. So there are things that that's kind of what you have to think about and be aware of. Plus just differences in screen sizes. So there's a lot more to test with in the Android world, and a lot of bugs that can arrive because of just physical and software differences and compatibility issues that you might not see on, say, a web platform to the same extent. Okay? So that can be part of it. There can also be maybe there's bugs in the Android framework that happens sometimes. Maybe there's bugs in the Java framework or it's not behaving the way you expect it to. Maybe you didn't understand the requirements for your applications, or you made some certain assumptions that didn't really hold up. Again, like maybe something as simple as the user, putting in a string where you meant them to type a number, or putting spaces where there shouldn't have been spaces. All of those kind of things. There's also limitations from the device perspective to things like not every Android device has a GPS chip. Most do, but not all of them do. Some Android devices have a SIM card. Some don't. So some devices may be able to get like 4Gs, and some devices they only can run on Wi-Fi. And so you got a lot of differences there. There's accelerometers that you can kind of measure the tilt of your device. There's also gyroscopes. Some devices have a gyroscope that will tell you more accurate rotation information, but not every device has a gyroscope. So you have to kind of be aware of all of those differences as you're debugging your code, and so there's a lot of tools that you may need to pursue to kind of figure that out. But when you're testing it locally, at least, and you have the device plugged in, that's where the debugger is really helpful. That's where that operates. One of the issues run into, though, a lot of times you'll have bugs that occur, whether it be your tester, you have people testing the application that are probably on your team or working at your company. But you also may eventually have, bugs that occur in the field with your actual end users. Sometimes those can be hard to replicate, and if it's somebody else's device and they've got code that, especially if they pulled your app down from the App Store, you're probably not going to be able to get into that and replicate it. You may not be able to replicate it in the debugger. So that's one of the reasons why having logcat, having log messages in there is a really big deal, because you can, even if they've, say, pulled it down from the Play Store or it's somebody else's device, there's still ways to look at logcat without having to have Android Studio plugged in. Does that make sense? And
easy question.
Yep.
What does logcat mean? Why that term? Is that like a change of catalog, or?
I'm not entirely sure where that term comes from. I know in the world of Linux, there's a program called cat, which is short for concatenate. And so cat, you can give cat a file name, and it will display that file on the terminal. So if I say cat myfile.txt, it will show the contents of myfile.txt on the terminal. So I'm going to guess that that's what it has to do with, is cat, as in concatenate it or show it in the terminal kind of thing. Basically, all you need to know is that it's a way to log messages that are then visible, whether by USB debugging or there's a Wi-Fi debugging functionality. You can see those log messages for any of the applications that are installed. Okay, which is the other reason when you look at that logcat thing, you're not just seeing log messages. You're seeing a lot of log messages stream through, because those are being, every application on the Android device logs to the same stream. Does that make sense? Everybody's logging to logcat. So, one of the things that means from a, just good coding standpoint, good coding behavior, do limit how much you log. Logs are an essential thing, but at the same time, you're polluting that log with your own logs. So be kind and don't log a bunch of data. Because if you log too much, it will eventually slow the app down, or in fact potentially their entire device down. Plus, you make it harder for anybody else that's trying to do debugging on that device because your app is noisy. So, Logcat, you can use the debugger, which is built into Android Studio, is great. We'll talk about that here. We can talk about, that's part of that. Tomorrow we'll talk about how to use JUnit. 6.1 covers Espresso, which also is for automated testing. As I kind of mentioned, we will be skipping that. Dalvik Debug Monitor, DDMS, can be used to track resource usage. So you can use that to track, it can actually graph how the CPU is being used, or graph how much memory is being used. You can kind of think of it like Task Manager for Android. That's really beyond the scope, though, of this semester, and not really covered here. But if you do care about performance, then and you do want to make you're having issues with memory, then that's the place to look, is DDMS, and you can get to that through Android Studio. Okay, so we're gonna talk. So those are kind of the things that are available. You've got Logcat, which we've talked about already. You've got the debugger. You've got automated testing with JUnit and Espresso and DDMS. So let's talk about how to use the debugger. So when we want to run our application, we actually have a few options. So if you're looking up here on the top, I'm going to go ahead and pick the Nexus S. Kind of bring this down. So when I want to start the application, and right now I don't have it running and I don't have my emulator up, you'll notice that there's a few buttons available in the toolbar. So one of those buttons is this green arrow. This is Run. Okay, so this one is the one that will run your app the fastest, but it doesn't run with the debugger attached. So if I click Run here, any breakpoints or any of these other tools that we're going to use, don't apply. You can't use them if the app is simply running. So to get these tools to work, you do have to start the application by pressing the debug button instead. Okay? So if I start it with the little bug here, that green bug, that will start it in debug mode, and then I'll actually be able to, debug the app. So if I look at the application code, You'll see there's a calculator. You'll see that there is a main activity, right? So there's both of those two classes there. Now you did see a menu kind of pop up there. I think if the dialog popped up there, that's related to the fact that it's in debug mode now. So what that means is now that it's in debug mode, I can use all of the functionality of the debugger. Okay? So keep that straight. You know, when you're starting your application, you can either start it with the debugger or you can start it with run. The reason those two exist is because this does having the debugger running does make the thing run slower. And especially if you're running it on an emulator, you may notice that. And even with the physical device, you may notice that because if it's debugging, the app kind of has to send information back and forth between your computer and potentially wait before it can do the next thing. So for instance, things if you're trying to test out animations, those animations are probably not going to be smooth with the debugger attached. Okay, so if you want to see smooth animations, you're going to need to do just run. Questions so far?
Nope.
Okay. So I've got those two buttons there, either run or run it with debug. There is also an option here if you say you've ran it, but you later decide you need to change your mind and you want to put it into debug mode. You can click this attach debugger, so that will attach the debugger to a program that's already running. So I can start it with the green arrow and then hit that and get into the debugger if I, maybe want to start it faster and then get into the debug when I know where I'm closer to the problem at hand. Okay, so those are a few buttons you want to know about up on the top, and they kind of mention that's the debug button, and so that's where you can find it. The next thing that we'll see here is once we kind of put a breakpoint in, there'll be another window down on the bottom. Okay, so I'm going to go back into Android Studio, and so you can see we've got these two classes. So we've got main activity, we've got calculator. It's worth noting that you can only put breakpoints in the Java code. There is no way to put breakpoints in the XML code. Everybody with me there?
Yep.
So if you have a problem with your layout or any of your other XML resources, that will crash your application. There is no way to attach a debugger that will tell you where that is. So you can only attach your breakpoints to the Java code, not the XML code. Okay. So in the Java code, the way you set a breakpoint is pretty simple. I just put it here on the left, and you'll see how I get that red circle with the checkbox, and you can kind of see that the line shows up in red, right? So what that means is when the program gets to this line of code, and before it executes, remember before it executes that line of code, it's going to stop and wait for me. Okay, so I can kind of then do things step by step and see what's going on. Okay. Now, to explain what that checkbox is there, let me go ahead and stop the app and just hit regular run. So now that I'm just running the application, you'll notice that checkbox is gone. Do you see that?
Yeah.
So that checkbox means that your breakpoint is actually in play, and it will actually stop at that breakpoint. If you don't see a checkbox, then either you're not running in debug, or there's basically no way for it to get to that code. So if you don't see a checkbox, then that means that something's up, and you definitely need to figure out what that is. Because your program won't stop there. So I started it with this. I'm going to now attach the debugger, and so it asks me which application do I want to attach it to. So I'm going to attach it to that running program, And now that it's attached, you can see that that checkbox has reappeared. So the most common thing that means is just that you don't have the debugger attached, but it can mean other issues as well. Okay. So when we have this running, and you'll notice right now, what line of code is this on? Well, this is a line 50, and this is where set content view, right? So right now the program's running, but I'm kind of already past where that breakpoint would be tripped. Does that make sense? So that breakpoint is tripped when the activity is created, right? So what can I do to cause to get back to this place, to get that breakpoint to trip?
Close it and reopen it.
Okay, so I'm going to hit the back arrow here on the left, on the right. Okay, so we're going to go back, and so we're no longer in the application. And so now I'm going to go back to maybe my home screen. And let's say this is Simple Calc. Okay, so I'm going to go back here and launch it from the start. Okay. All right, so my breakpoint got tripped, and you can see I've got a white screen now, right? So it's white because it hasn't had a chance to draw the screen yet. I'm pausing it. So until it goes far enough to be able to draw the screen, that's going to stay white, okay? Because that's where it's at in the code. So right now, it's right before this line runs, okay? So if I wanted it to be after that line of code ran, then I would want to put the breakpoint here, right? So the breakpoint is always before the line of code you put it on, okay? So I'm going to put breakpoint. I've got my breakpoint here. I can see now that it's stopped at that breakpoint. There's a few different things down here that I can see. So the left section is called frames, and that's where you see what we call the stack frame. It's the chain of events that have led you to this line of code. So for instance, in here we can see that on create, okay, on create we're on line 50. That's the colon. So on create line 50, we're in main activity, and this is the Simple Calc app, right? Now, the very next line tells us what called that. So if in this case, because we're in on create, there's not really much interesting down there, right? So because what called on create? Well, it's the Android operating system, right? So all of the stuff that you're seeing down here is all of the functions that are actually in the Android operating system that led to your particular app being called. Okay. Honestly, we don't care about anything that's happening below our app, generally speaking. So generally speaking, you only have to concern yourself with the function calls that are within your program, and that applies to most programming languages, most technologies. If I'm debugging, I just care about debugging my code. Okay. So that will tell me where we're at. So we're on create in line 50, and over here you can also see that I can see the variables, the current state of those variables. So for instance, I can see that they've got this mCalculator field, which they've defined up here, is currently null. I can see that the save instance state is null. Why would that be interesting to me to know whether or not the saved instance state is null?
Well, you got to check on that later,
Okay.
right? To see if there's anything to save. So once something's inputted, then that would automatically change, right? We should be watching for that.
Okay. Somebody else give me an answer. Why might I care if saved instance state is null?
To see when it gets instantiated.
Okay.
Because once it gets instantiated, that means your project starts running.
Now, what are we talking about instantiated? Are we talking about the activity being instantiated, or are we talking about the bundle being instantiated?
Well, that method, right? That method is currently null, and until that a method gets assigned, which is later on, that's when. Oh yeah, the bundle. Right.
So I'm talking. Which method am I in here? I'm in the onCreate method, right? Method is a function, right? So the method I'm in is on create. Methods don't get instantiated. They don't get created. They're not objects in the Java world. So you can't instantiate a method. Just so we're clear here. So yeah. So when does the bundle get instantiated? You know, what actually makes that bundle?
Isn't it when it gets called? Or
When the bundle gets called?
yeah.
Okay. Well, what can you call? You can call a method, right? You can call a method. Is a bundle a method?
No.
Okay. Well, what is it?
It's a function. But didn't you say it was a function? Or wait, a bundle's object.
A bundle is an object, right? Bundle is an object. I can't call an object. I can call a method. I can't call an object. So you kind of have to you have to understand the terms that you're using, Mo. Okay.
Yeah, my bad. I just get mixed up with it because we just came from JavaScript, and it was.
Well, still. So remember we talked about this on Wednesday last week, right? So we looked at the save instance state. Why did we care about the save instance state in 2.2?
Are you talking to me?
I'm talking to the class.
That was in case we have a configuration change in order to maintain the information.
Okay.
It probably has other issues too, but I think it was mostly going from portrait the landscape, you lose all the data.
Yep, that's the most common one. So if we kind of remember from 2.2, one of the things that we remember saying in there is that when the app goes through a configuration change, it will be destroyed and recreated, but in that process you get to save your state and restore it. So one of the things I know here is because the saved instance state is null, is that this was not a configuration change, right? So let me go ahead and hit run, and we can kind of look at this. Run, we'll put it back into operating mode. You can also do that from here, and that's actually usually the way I do it, is just to click the green arrow there. I'm going to now turn it sideways. That onCreate should get called again. Oh, but now I'm not running with the debugger attached, which is why I don't have the green check mark. So I need to go back in and run with the debugger. Okay. So I'm here. I'm going to hit continue. Sorry. I don't want to push that button up there. I want to push up here. So this resume button here will get it back to running. So go back to running. I'm going to then turn it sideways. And so now that it's turned sideways, we can see that onCreate has been called again. But notice at this time that saved instance state, that bundle is not null. Does everybody see that?
Yeah.
So that gives you, that's a very easy way to look in there and see what's actually in that bundle and see, in the scenario that you're trying to test with, is there data there and what data is there? Because that can be very interesting for a lot of different reasons. I can also, now that the bundle's there, I can kind of open it up and look inside of it. So I can just hit that left arrow, that'll drop it down, and I can see the properties of that object. So for instance, if I drop that down, you can see that object has a bunch of fields inside of it, right? And it's actually letting me see now the private fields inside of that object, right? And so, that's kind of interesting. Generally speaking, in your code, you can't get access to private fields, right? You can't usually read those values, but the debugger can read all that, right? So
you're in the same class, aren't you? So you should be able to see it if you're operating within it. Yeah.
I'm in this debugger thing. There's no way it's in the same class. That rule doesn't apply.
All right. Okay.
So one of the things to understand, anytime you're thinking about writing stuff in terms of object-oriented programming, remember that those access modifiers, public, private, protected, all of those only apply to the kind of code as you're writing it. When the program actually runs, everything's public. There is no such thing as a private field at runtime, and that doesn't matter what language you're writing in. Does that make sense? So, if I want to read that memory, I can read that memory. So the debugger is able to look at the memory inside of there and kind of see what's there. So we've got, class loader. There's another object in there I'm not so interested in. You can see flags. But you can also kind of notice just from the names, right? You notice how they start with that lowercase m. Most of them do.
How did you get to that drop-down list from saved instance state?
I just clicked right here. That little triangle.
Oh, okay. Mine didn't pop up with a little triangle.
Okay. I don't know why it didn't. It may be that it's still null. If it's null, it won't give you that triangle. But this is because I kind of did it after the rotation. Right? So
Okay.
I hit resume the first time and then turned it, and then I'm back in here.
Okay.
So it may be that it's probably that it's just still null. So remember that M actually, that's a naming convention. It stands for member variable. So you can kind of see that the actual Android code behind that, well, they're using that convention in their code as M being a member variable. Okay. Now, I probably want to look at where the actual data is inside of there. And so that can be a little bit difficult because, typically the way we read and write from this saved instance state from these bundles is typically I use the functions like getInt or putInt, right? Those are the methods that we use. But you don't have access to those methods when you're looking at the debugger, okay? Because that would mean running code, right? But the debugger is only able to look at memory. So if I want to see what those values are, I have to kind of look at the structure and search for and find them in the way that those are architected. Now I'm going to guess, just an educated guess, I'm going to guess they're probably here under mmap. A, because I can expand it and see there, and B, oh, I kind of know what a map is. Okay, so I'm going to click down on that, and we can see, okay, this looks like something that's an array, right? So I got value 0 and value 1. Let's let me expand down there further, and let's see if I can see what those actual values are. So go down to value 1. Interesting. There's another map underneath it. Okay, maybe value 0. Maybe there's another thing there. Okay, so I finally go down to keys. So you can kind of do a lot of digging here, and unfortunately sometimes it can lead you down to a rabbit hole. So some of this stuff is not always easy to kind of figure out, if that makes sense.
What's the reason we looked at that? We're just asking what mmap is?
Yeah, just asking,
Okay.
what I mean, this structure here, mmap, is what's backing the actual data in the bundle, right? So if I wanted to see that my data that I stored, right, ideally I stored the data in saved instance state, I'd need to dig into this object and find that data, right? Now, I don't know that anything's being saved right now in here because I don't think on save instance state is implemented. Yeah, it's not. So we won't find anything particularly interesting in there right now. So we'd probably need to implement that and then come back. But you can kind of troll through the objects and look for your values using that. Okay, so next things. So once I'm on this line of code, I may want to kind of move on to the next step. So looking back over here to the buttons on the left, so working our way from the top. So if you're at a breakpoint and you want to go back to running, you can hit resume program. If you just want to terminate the entire app and go back to, say, the home screen or wherever you were previously, you can hit stop. So that will stop the app entirely. You can click this button here, View Breakpoints. So this will show you all of the breakpoints I have installed. So right now I just have one breakpoint on main activity line 50. If I were to say put another breakpoint over here in calculator, maybe on line 31, then I could come back in here and I would see both of those two breakpoints, right? So as your programs get bigger and you have more classes, that could be very helpful to kind of go and see where all of your breakpoints are.
Did you show us a step over button? Is there something like that?
Yes, there is. There is.
Okay. Did you show that and I just missed it, or?
Nope, I haven't gotten to it yet.
Oh, okay.
It's on that toolbar. So we're kind of working through that toolbar. So you can show all your breakpoints. That's what that one's about. You can mute your breakpoints, and so what that'll do is that means that your code won't, and you keep your breakpoints, but they're all disabled, right? So you have the breakpoints installed, and you can still see where they are, but if your code gets there, it won't actually stop. So that can be helpful to kind of get to, you can mute the breakpoints, get to where you need to test, and then unmute it. So that way it's not firing off a bunch until you get there. There's also, a dump here for the threads. We're not really going to touch that. That's beyond the scope here. There's some settings and their pin. So then kind of run. So that's the buttons on the side. So those top few are of interest. The pause button, by the way, here, if your program's already running and you just want to stop it and see where it is running code right now, you can hit that pause button and that will break it wherever it is. So that can be interesting if you have like a long running process. Like the program looks like it's stalled and nothing's going on. You can use that pause to see maybe where it's being slow. Because it can be hard to kind of figure out where to put the breakpoint. So you're asking about step over. That's these buttons over here. So you've got step over here, shortcut key F8. You've got a step into, and it says force step into. I don't really think you'll need to do much with that one. So the red ones are not as interesting. It's the step out. So you've got step over, step in, and step out. Okay, so those are basically the keys that we're interested in. So step over will go to just run that line of code where you are and go to the next line of code. So that's basically what step over is. It's just run that line of code, go to the next one. Okay. So that's
Okay.
most of the time most of the time that's the one you want to use. Most of the time you'll use step over until you get to where you are and you know where the problem is, until you're there. If you then kind of figure out where the issue is, you may need to step into a particular function call. So in this case here, I'm on line 54, right? If I were to step over, it would just go to the next line, 55. But if I step into, it will go into the particular function call that's on that line, right? So what's the function that's being called on line 54? What's the method that's being called?
Find view by ID.
Find view by ID. So if I hit step into, that will step me into find view by ID, right? So now I can see what the implementation of that is. So the implementation here is first it calls get window, and then it calls get view by ID, right? So again, here I have an option. I could step over. Step over would just take me to the next line of code, which is 3354. And from there, well, that's the end of the function, so where is it going to take me? If I step over.
To see the other code,
Okay.
right? Because it would be back in that window, right?
That's all I'm looking for.
We wouldn't
It
be
would
where
go
we're
back.
at.
And in fact, it's actually visible here. Look at my stack frame.
Yeah. Generally, though, the step
Mhm.
into that's truly the step by step of going through the code.
that's
in
that's
more detail and more of a rabbit hole than we need, right?
yeah, usually more than you need. Usually more than you need. But that can be helpful to debug. Oftentimes you may want to debug into your code. Usually what I do is a first pass of just step over, step over, step over until I find out where it is. And then I'll go back and do the same, do it again, and step over until I find the place that I'm interested in. So I usually kind of use both of those in concert. But we can see here that we are on create line 54, and then we're in find view by ID. So we actually know if I were to go to step over, it would go back to on create line 54. Now, it's worth noting on here, there's two function calls, get window and find view by ID. Which of those two is called first?
Get window.
Okay, get window. So by virtue of that, if I hit step into, it's going to go into get window. Okay, so I can keep hitting step into there, but that it's just returning m window. So whether I hit step into or step over, in that case, it does the same thing. Here I'm now back here. And this time if I hit step into, it won't be going into the get window function because we already went through that. It'll be going into find view by ID.
Yeah, it's every single step.
Yeah,
Nothing
it's every
skipped.
single step. So that does mean a little bit of a thing that you should take note there. If you have more than one function call on a particular line, your code is inherently going to be harder to debug. So code that only ever has one function call per line is always easier to debug. Does that make sense? So you can do a lot of chaining and nested function calls. You can do a lot on one line of code. But if you only have one function call, you will find it easier to figure out your issues. So do be careful with that, kind of how deeply you nest and things like that. So we're in here, and once you kind of get in those weeds, we need some way to get out, right? So the way to get out of here is I'm just going to say step out. And so if I step out, it will go ahead and run the rest of the code here and basically run me down until the end of that function, right? So if I set step out, it's going to run the rest of this method and then come back to find view by ID. Same way I can hit step out here, step out, and eventually I'll get back to where I was. So you can use those three buttons, step over, step in, and step out, to kind of navigate around the individual lines of code. And you'll see as I do that, the variables that it displays here changes. So for instance, we're here on line 56 now. We can see that operand 1, edit text, that's set to a value now. Notice that m operand 2, edit text, you see that's not set to a value, right? See, that's set to null. But I'm here on line 56. It says m operand 2 equals find view by ID, right? So shouldn't there be a value there? Shouldn't there be a value for operand 2 edit text?
Not yet. You
Why
have to
not?
step through it.
Okay, why not?
You have to go through it, right? We're not on that.
Right.
We haven't gone through that part, right?
Right. That line of code hasn't executed yet.
Executed, yeah.
And so that's where a lot of developers make the mistake, especially new developers. They look at that and they say, "Oh well, operand 2 is the thing that caused my null reference exception." Does that make sense? But that's not true, because no, in the end it won't be null. It's just null right now because that code hasn't run yet. So a lot of times I see students kind of stop there and say, well, okay, this is my problem. If you just go one step further, I now see the operand 2 has a value, right? So sometimes you have to step to that curly brace that curly brace is actually considered a line, basically. Does that make sense?
Yep.
So make sure that you're stepping usually I put the breakpoint before it's going to happen, and then recognize that you need to step over the thing that you're interested in actually seeing how it behaves. So in here you'll notice that I've got it's decided what variables to show. But as it turns out, those are not all my variables. So for instance, notice right now that it's not showing me the value of operand 1 edit text. Do you see that? And it's not showing me the value of mCalculator. So what could I do? There's two ways to solve this. What could I do to try and find, say, the value of mCalculator? Anybody?
I'm not sure if I understand. I mean, we're just creating the calculator. We're creating an object, right? But we haven't really done anything with it.
Okay, but I want to see the value of it. I want to see, what are the fields of it.
The plus is that a watch list like in Chrome Developer Tools?
So there is a watch list. Yep.
Okay.
So that's one option. I can add it to the watch list. The other way I can do, you see there's the this up here. Well, this refers to main activity. So you remember that this is short. mCalculator is short for this.mCalculator. So I can actually expand this and see it here. Does that make sense? So a lot of times your member variables, they might disappear. You just need to expand this and you'll see it there. But you're right. If you want to add it, I can just say plus, and we could say mCalculator, and I could see it on this list, right? So that's all you got to do to add and remove watches. So add a watch, you hit a plus there. You want to remove that and stop watching it, you just hit minus. So you can add additional things that you want to monitor that way. Okay. All right, so we've got kind of an introduction to where those things are. So now maybe the best thing for me to do is to kind of try the application and see if it works and see if I can find any bugs with the application. So kind of walking through this together, what should I try first? Again, my goal is to see A, is this program working? And B, to find any bugs that it might have. What should I do?
Why don't you just run it without debugging just to see if it breaks?
Okay. I'm going to run it. I'm going to keep it with debugger here. But I can pull my breakpoint out. So just judging from the UI, what would you expect this application to do? You know it's a calculator, right? There's a button named add, there's a button named sub, div, multiply, right?
I feel like you should be able to type one number in the top, one number in the second line, then you can add them up and it should output the number.
Okay. So that's a reasonable expectation, right? So give me some numbers that I can type in.
Just do 7 and 9.
Okay, so let's try 7 and 9. And so we know that if I hit add, that should say 16, right? So I'm going to hit add. Okay, so we've got our expected behavior. All right, somebody give me another test case.
How about you try dividing numbers that can be dividable?
That can't be divided?
Yeah, so like 5 and 2. Well, they can be divided.
So before I do that, do I know that the division is working?
No.
No. Okay. So I probably should start with numbers that I know should work, right?
So 4 and 2.
Okay. So if I say 4 and 2, then that should give me 2, which works. Okay. So then you say numbers that can't be divided. What
Well,
do
they
you
give
mean?
you an uneven remainder, so like 5 and 2 or 0 and 2.
Okay, so let's try 5 and 2. Divide. Okay, so we got 2.5. That makes sense. So we can see that this is working with floating numbers. as far as the results is concerned. So it can give me answers that aren't whole numbers. Or I could say, 1 divided by 3 is another good one. And that one's especially good because it doesn't end. So, okay, 0.3333, and I can actually see now, when I just did 5 divided by 2, it looked like it was always rounding to 1 decimal place. But we can see with 1 divided by 3 that it's rounding to a lot longer than that. Does that make sense? Okay. So I can see a few things there. Okay. So far we have found one issue there that maybe it's not consistently formatting it. And maybe I'd like to have it do the same number of decimal places. So that's one issue we might want to look at. What else? What else can I try?
You could try dividing by 0 and see how it handles that error.
Okay, that's a really good thing to check. So 1 divided by 0. The answer is, it says that's infinity.
Awesome.
So it didn't crash. So we know that much. But it also didn't say, like, you can't divide by 0. What else? Remember, we're looking for to see, does this program work, and to see, can we break it? Okay.
You could try to put letters to break it.
Okay. So let's try letters. So what should I put in the first field? Do I put a number or letters?
A letter.
Okay. So what letter?
A.
Okay. So A here. So we're going to put a single letter A.
I don't think we can.
When I press A, it doesn't let it take. Okay. So if I press the letter A, at least it appears that I can't put anything there.
What if
Is it?
paste a letter in, like copy from somewhere and then paste it in?
That's a very good question. Yes, because sometimes you can paste, but you can't type. And that doesn't work here. So that's good. But that is a great thing to test for, Mo. That is a problem sometimes.
Why would you be able to do one and not the other?
Because sometimes it's poorly coded.
It would be just an edit text, right? That's all we would put there.
I know. Yeah. I'm talking more generally. If you're testing anything where it's a text field that should only take a number, including stuff with like web, there's a lot of poorly coded websites out there with JavaScript where they use JavaScript to detect changes to the field, but it only checks when you type the letters and not when you paste something from the clipboard. So it depends on what, in this case it works, right? Because it's been implemented properly. Does that make sense? It won't,
Yep.
But sometimes those are different. Sometimes pasting and typing are different. Okay. So it appears I can't type letters in there.
It just won't let you do it.
Just
It's
won't
not
let me
like-
do it. Yeah.
Even like apostrophes and stuff like that.
Well, that's a good question. I could just type a dot. That is actually legal. Okay. So I'm just type a dot. Which button should I then push?
Add.
Okay. So let's say add dot and 0. All right. So we got error is being output. Okay. So we found something. And Vincent, you were asking about just a minus, so I can try just a minus here. But you can see it won't let me type just a minus. I can type just I can't type just a comma, and I can't type just a minus because it does require me to put other characters in there. So for instance, I can put one. Where is it? -1. Okay, actually it doesn't seem to let me put in negatives at all. That negative doesn't seem to be accepted.
Maybe it has to be in the first position. Maybe like test for like the first index.
Yeah, it doesn't. I think that button is just disabled.
Yeah, I mean, I don't know if this is just the emulator, but when I'm on my tablet, I don't see the option to add a negative sign. So
Okay. So that would be a difference in keyboards. So basically, I think the reason that these buttons are here all the time in this case, and because the phone keyboard is usually the same as the number keyboard. It's usually a very similar keyboard layout. So basically, this stuff is here and would be enabled if we change the settings on the edit text. Okay, so we've determined a few things there. Okay. What else? Have we figured out if the add button works? Just kind of working our way down. So from the add button, what do we know about the add button now?
That it passes all of our cases.
Does it?
except a non-number.
Okay, so a non-number, it just shows error, which, okay, so it doesn't crash, but is that in the intended behavior, right? So in order to know that it passes all your cases, you have to know, well, what the intended behavior is, right? Does that make sense? Right?
Yeah, intended behavior for if there's an error, it's the display error.
Okay, so if that's the intended behavior, then okay, we'll take that. If that's what it's supposed to do, then fine. But you do have to define that, right? And maybe the right answer is that the error message should have been, please type a number, right? Maybe it shouldn't have just said error because something went wrong. Sometimes a more descriptive message is a need. Okay, so what about that one? Have we tested the subtract button yet?
Nope.
Do we know if I click the subtract button if it will crash the app?
No.
Okay, so what do we need to test with the subtract button?
5 and 2.
Okay, so let's say 5 and 2. Okay. All right, so that makes sense. Other things, what else can we try?
Try getting a negative number, so 2 and 5.
Okay, so I can flip those around. And so that's kind of the, this is part of what I wanted to go through today is just, thinking about, how can you test your application and how can you make sure all of your bases are covered, right? Okay, so that seems to work. Anything else we should try?
Empty fields.
Okay, empty fields. So maybe I try one of them being empty. Okay, that one gives me error. I can try it the other way, and that one gives me error. Do make sure that, if you're testing those things, do test it both ways. I have, there are ways to write the code where it might work for one field being empty, but not the other field being empty, right? So just because you test one doesn't mean you've covered the base for the other one. Okay.
I'm guessing, is there no way that we could take the final total and be like, hey, it's, maybe divided by this, it's just whatever's in those two lines?
Yeah, it's just those two lines. It's a pretty simple calculator.
Okay, what about hitting just like add and divide, multiply, subtract, just kind of running the buttons
Okay.
constantly?
So let's put some values in. What values should you put in?
I think we should just do 1 and 1.
Okay, so 1 and 1. That's a pretty good thing to test because I can try that with all 4 of those. So I can try add. Okay. 1 plus 1 is 2. Subtract. 1 minus 1 is 0. Divide. 1 divided by that is 1. And then I hit multiply. Did multiply work?
I'm sure it did, but we have no way to say
You have
it,
no
really.
way to know because it didn't change.
So why don't we do 1 and 5?
Okay, I could do 1 and 5. What else could I do? I could just hit add. Now it's 2. And now it's 1. But it would be reasonable to try some other numbers, just if the order matters. So divide, 2 divided by 1 is 2. Oh, nope, I need to do this backwards. 1 over 2. So 1 divided by 2 is 5, and that's 2. So there I can clearly see that it's working. So obviously, the values you test with determine, what you can see is working. So it's always important to pick good values, right? Okay. So we've got some basic checking there, and I could do kind of going through that same approach. I could say, well, let's leave the second field blank. Error, 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 error. Okay, nothing crashed there. Go back to here. Top one. Do it. So far we've not found anything that makes the application crash. Okay, which oftentimes is the main thing you're looking for, but isn't necessarily the only thing you're looking for. Okay? Everybody with me there?
Yep.
So just because it doesn't crash doesn't mean that the application is working. Now, there's one big group of cases that in all this here we haven't tested. Okay, so we've checked for blank. We've determined that we can't type in laters, and we've tried numbers. What have we not tried?
We tried everything.
Nope.
Maybe really, really large numbers, like multiplying, say, 2 8-digit numbers, something like this.
Okay. All right, so if I at least start with one large number and multiply that by 1, okay. I'm seeing some behavior that I haven't seen before, right? So a 1.111111 E661. What does that mean? What is that E61 about?
How many times you want to multiply that number by 61 to get the true value?
Nope, I'm not multiplying by 61. Somebody else.
It's 1.1 whatever to the 61st power.
Okay, you're close. That's not true either.
Times 10 to the 61st power.
Yes, 10 to the 61st. If I were to take this number to the 61, I would get a different number. So it's times 10 to the 61. So you can think of this as like scientific notation. So I can see there if I take a really large number, I'm going to see something like that. I can do the reverse and put that really large number in the bottom. So 1 and 1, 1, 1, 1, 1, 1, 1, 1, 1, and hit divide. And so I can kind of see the reverse, right? So if I take 1 divided by a large number, I get this 9.0 e to the negative 71. So we can see that for large values, it's being represented as scientific notation. Okay.
So stop me if I'm jumping ahead a little bit too
Yep.
far here, but does the text field that is in right now, like where it says 8.99 repeating, does that automatically just like add that E in there, or if it was longer, would it continuously add numbers onto it until it got to a final stopping point?
So there is a final stopping point. If it's small enough, then it will go to 0. So if I take 1 divided by a really, really big number, it will eventually go to 0. Okay, because it's roughly 0. That's how floating point numbers work. If I say multiply 1 times a very large number, it tells me infinity. You see that?
Yeah.
So with floating point numbers, that's where it exceeds. If this was running with integers, then that would have been an exception, right? So both of the, or might have been an overlap. I might have seen, negative. If I had done this with multiplying integers, I might see an error because it's too big, or I might see a negative value depending on the calculation. So
these are pretty reasonable outcomes, though. I mean, that's what you'd expect. It's not like I'm thinking there's going to be like 800 decimal places there.
Yeah, but you kind of got to check. And one of the things I did see with there, I do see with those two fields, is there a limit to how long I can how long of a number I can type in?
No.
There's not, right? That's a bug. Do you understand that? Because there should be a bound on how big of a number I can put in there. Right? So that actually I would consider a bug. The fact that it doesn't have a maximum length is a bug, because that's a reasonable thing for there to expect to be, is that there's a limit to how long that could be. Now, I have checked values where they come out as floats. Have we tried to put any floating point numbers in? Have we tried to put numbers in with decimals? What happens if they're using maybe integer.parseInt? Because if they're doing that, this program would have all the same behavior that we have right now, but it would crash with decimals. Does that make sense? Everybody with me there?
Yep.
Yep, I get it.
Okay. So what do I need to try?
2.5.
Okay, 2.5. Okay. So that one's covered. Right? But we could easily go in and break that and see if that occurs. So both of those values are being accepted as doubles. So we can kind of play around with the application, see what it's doing and where some of those error points might be. So what I'm going to do now is maybe let's see if we can introduce a fault and then diagnose it, work back from there. So if I say, let's go into, I want to find out what this add button does. How can I go find out where the code is for the add button? Where do I need to go? Because if I'm going to put a breakpoint in, right, I need to find the code first.
Could put a breakpoint on line 62.
Okay, so that's a good start. So if I try to put it on line 62, it actually expands because it kind of collapsed. So it's now actually on 63. I'm going to hit add. And it's not hitting my breakpoint. What did I miss?
Are you running with a debugger?
I'm not. How can you tell?
Because you don't have the check mark on the red circle.
Good. Lesson, at least one lesson learned there. Okay, so 2 and 1, and let's say add. All right, so now I'm at my breakpoint, right? So I can see that it's calling compute, right? And then it's passing in this value add, right? All right, so, and I also kind of notice if I hover over it, it says null. That's a misnomer. It's not actually null. What can I do to then find out, what button do I need to push to find out what's going on from here?
The step into.
Okay, so let's step into, and that'll take us into the compute function. Now it looks like it took us into the compute function, or it took us into add on the calculator class. But how did I get to the calculator class? Because the place I just was, right, this said compute. Shouldn't I have been in the compute class? Or the compute method?
No, because you're calling the calculator.
Okay. So what am I calling on calculator?
The operator and add.
Okay, so .operator.add. So it took me down here to, okay, it did take me to operator. All right. So I can step over and kind of get back here. Okay. And then we're back here, so let's try step into again, right? And so, okay, now I'm actually in the compute function, right? And which class is this compute function on? Zone main activity or zone calculator?
Main activity.
Okay, so we're here on main activity compute. We're all the way down to line 96. You'll kind of notice that line 93 and 94. Do you see it actually skipped over those?
Yep.
So that's because those aren't those are lines in our kind of reading. They aren't actually lines of code because they actually don't do anything. Right? There's nothing happening on line 93 and 94. We're just declaring a variable, right? And so that doesn't do anything. It just says, here's a space in memory, and I'm going to give it a name, right? So it's not actually a line of code, and that's why it will skip that, because it's not what we call an instruction. Because anytime you're doing step over, step into, etc., it's actually going by instructions, not actually lines. So you can see a little bit of discrepancy or interesting behavior there because of that. Okay, so we're here on this line, operand 1, right, and operand 2, and we can actually see already some of the code that's happening. So we can see that there's a try-catch block here, right? So try-catch, if there's a number format exception, then we do something with it, right? So we can already see that maybe there's some error checking there, right? And so I can guess from that there's probably a reason that error checking needs to be there. Reasonable assumption, right? Okay. So a good question to ask when you have a try-catch like this, a good question to ask is, well, what's throwing that exception? So what's throwing that exception? What's throwing the number format exception potentially?
This is the conversion of whatever's entered in the text box when we set that to the operands.
Okay. I can guess that that's probably part of it. But I haven't actually found a code that does a conversion yet. Because at least looking at line 96, I don't see a conversion happening there.
Would it be in get operand?
Probably would be a good place to look. Okay, so let's step into that. So I get into this get operand function. I'm still on main activity. So there's 2 lines of code here. The first one says get operand text. Okay. So maybe I want to troll into that, right? So I still don't know what's necessarily happening here. So if I troll into get operand text, that takes me down here, and I can finally see, okay, they're calling get text. We have an edit text here. Okay. And you're calling get text in toString. Okay. So get operand text just pulls the string out of the edit text. Okay. That's good. That's not a problem. So we can, that's not going to cause any sort of format exception. It could throw this method could throw a null reference exception. Under what conditions? What would cause that method to throw a null reference exception?
If the edit text is null?
The edit text is null. Okay. So that could be a problem that I haven't resolved. Okay. That would be worth kind of messing around with a little bit. But for the moment, I'm going to step over and get back up here and kind of look at the next line of code. Okay. So here, this is where the actual conversion is happening, right? So on line 134, see in get operand, line 134, it says double dot value of, right? So double value of is taking a string and it's converting it to a double. Everybody with me there?
Yep.
Okay. So let's say I'm going to just stop the program here for a minute. And let's just say I were to do one little change here. 134, I'm going to say integer dot value of. Now, I do need to do a little bit of a cast because it wants it back as a double. Actually, if I just change this to a lowercase d, because it was an uppercase d, so I say take it, parse it as an integer, and then pass it back, right? So I should be able to see 1.2 and 3, and let's try to, or, well, 2.5. Let me make both of those. Let's try to add, right? So now that gives me an error, right? So I said 1.2, 2.5, and now it just says error, right? Well, that's not, okay, so let's say I don't know that that's what happened, right? What would we want to do to go kind of find that out? Well, I'd probably want to go, if I'm going to debug that now, I'd probably kind of walk back up, right? And say, well, okay, well, we started with the onAdd method. And so I'm going to hit add here. And I kind of follow through that same process that we did. So step into, and I'm going to be down here, operand1 dot get operand. Okay. And so if I step into this method, so far everything looks good. I get down here, we can see the operand text is 1.2. Everybody see that? It's showing me the current value. So I can see up here, I can also see it down in my variables, right? And then if I try to step over, okay, then I get a number format exception. So it's interesting to note there, right? So typing in letters gives me a number format exception, but I also get the same exception if it is actually a number, it's just not the format that is valid. Does that make sense? That it's expecting.
Yeah. One of the things I don't understand is when we're catching an error, and in this case here, number format exception, that is, at least on the surface of it, quite specific. It's not just any old error. It's a number format exception. So if you get an error that's not a number format exception, what would happen? It would just carry on and you wouldn't see anything in the display?
It's a very good question.
For every single type of error, or at least have a general case.
That is a very good question. So I'm going to stop this real quick. I'm going to put this back to double. So I'm going to fix the problem that I created and put the code back. And now what I'm going to do is off on the other side of things, I'm going to make a change to the code, and we can see if we can figure out what that problem is. Okay, so I've made a change somewhere in the code. It's now broken. Okay, so I'm going to run the application. Actually, I want to run it with the debugger attached. Okay, so I've got a bug in my application somewhere here. And so that bug is going to manifest when I type in two numbers. So I'm going to type in two numbers and click add. Okay. And watch what happens. So type in two numbers, click add. I'll tell you, I've only changed one line of code. Okay, so I still got my breakpoint in here. So we can kind of, actually, let me go ahead and just run so we can see what happens. My application crashed. Okay, so this is what's happening now. If you type in two numbers, it's crashing, right? So if I type in 4 and 2, hit add, I'm going to say it's crashing. Okay, so that's what your tester tells you, right? Here's your program. This is the behavior, right? So what can I now do to determine why it's crashing? How can I use the debugging tools here to figure out what went on?
I'd look at the cat log and see what the last thing is, what looks like the error, and go and make my breakpoints off of that.
Okay, so that's one possibility. The other possibility is we know we're clicking the add button, right? You with me? We know we're clicking the add button, so I know that if I put it here on add, it's going to get there. And oh, I need to have the debugger attached. Okay. So kind of thinking here, right? So I'm going to hit add. It's going to stop here, right? What should I do from this point? I know it's somewhere in this adding. Where should I go? Step over, step into.
Step into.
Okay. So step into. Hopefully that'll get me somewhere. All right. Probably not interested in what's happening here. Okay. So I stepped over. I'm back here. What now? Do I step over or step into?
I thought we just did a step into.
We did. Right? And that step into, though, took me to calculator class to go look at the operator thing.
You want to step into again to find the compute.
Right. We need to step in again to actually get into compute. Okay. Now what? What do you want me to do now? Again, we're trying to figure out why the program's crashing.
Why don't you step into it again? Like
Okay.
Step into the line?
All right, so let's step into this code. Okay. So far hasn't crashed.
So step into it again if it hasn't crashed.
Okay.
I'm guessing just keep going until it crashes.
Okay, but step into or step over?
Step into, because you wanna hit the line that crashes.
Okay. Do I really want to step into here? I probably don't. Notice where it takes me. It takes me to view. Right? I'm no longer in my code, right? So I probably don't want to step into there. I probably want to get out of here. Which I kind of see something's going on weird there. Now I'm in all sorts of places. So I'm going to hit run. Right. So word of warning, right? Why did we go wrong there? Well, we were trying to step into get text, right?
I thought I saw on one of the previous screens that operand edit text was null.
Aha.
That
Yes,
too.
you did. Yes, you did. Right. You did see that. So you saw that it crashed. And so I'm going to step back into and get back to where we were. Nope. And I pushed the wrong button. So I'm going to get back into here to add. And so step into, step over, step into. And yeah, if you're paying attention at this point, right, we can see that the operand edit text is null, right? And so that becomes a problem here. So this is where it's crashing, right? So this is the line of code where the crash occurs. So we know that the program's crashing. We know it ends up crashing because here I say operand edit text and get text.toString, but as you're saying, this is null, right? So what kind of exception does this end up throwing?
Null reference exception or null pointer exception?
Yeah.
One of those.
I believe it's null reference exception. I forget because C# and Java used the one and the other. So we had null reference exception, and so we get in here, right? But what actually causes the null reference exception?
I think we got to go a little bit earlier than even on this page.
Okay.
It was the parameter or the argument. It was the argument to what's called on 132,
Right.
and it never made it to line
So, Paul?
132 being correct.
You're answering a different question. You're asking the question of how did it get to be null? I asked the question of how did we get the exception? Right? So we got the exception because what here triggers the exception?
We're trying to turn null into a string.
Okay. So it's the toString call?
I'm not sure.
Okay.
Say that you got to get the text to turn it to a string, so get text is probably the problem.
Okay. Yes, get text is the problem. So the problem is not the problem is not those. Remember, anytime you dereference something, you dereference a null, right? That means we look at the reference and we look at where it's pointing to. If it's null, then that's where it throws an exception. So in order to do things like if you have an array, remember if you do the index, that's a dereference. Anytime you try to access a field or a method of something that's null, that's where you get the dereference and it happens. So it doesn't actually matter what the method is here. All that matters is we're calling a method on something that's null. Does that follow? It doesn't matter what this method was. Any method on null will give you a null reference exception. Okay? All right. So you're right. So we want to find out how it got to be null, right? So I can use some tools I have here, right? So I can actually use my stack frame for this, right? So we know in here this variable is null. I can go actually up in the chain without moving, and I can see that it's null here, right? So it came into this function null. Where can I go to next? Probably further up the chain, right? So I know it came into here, it was already null. I go back up here, and we say, oh, m operand 1 edit text is null. Do you see that? So what maybe is the source of the problem, given that we know that this variable is null? Where would you think to look? Because nowhere in this chain of code have I set that variable, right? We haven't seen that variable assigned. So where should I go look?
On create.
Probably on create. Why would you guess on create?
Because that is where we use that R find view by ID when the activity is created.
Okay.
Or make m operand 1 edit text equal to something.
Right. And so you're making a good assumption that you're kind of like, okay, this is where most programs do it, right? So most programs do it in onCreate, so it's probably up in there. But that may or may not be the case, and we'll come back to that in a second. So in your case, you're right. Right, so the whole point it crashes is because we didn't set it. Does that make sense? Okay, so that gives you kind of a way to track down some of those exceptions. You just kind of step through it until you see it crash. Now, the thing that's worth noting there, and you were asking, you noticed that it did catch this exception, but it didn't catch we didn't check for null reference exception, right? So because we didn't check for that, we didn't catch that, that made the program crash. So does that answer your question, Paul?
Can you say it again? Why that is? I'm sorry.
So we don't have a catch here for null reference exception.
Right. Mm-hmm.
Right. We don't have a catch for null reference exception. So if say I forgot to do the find view by ID up here, and I don't have the catch, that would crash the program. So I might want to go down here and say, well, let's just guard against that. Oh, so it is null pointer exception. And so I might say EX here, and maybe, okay, well, we want to do something with that exception, right? So what would be a reasonable thing to do with that exception?
Probably just say one of the values, just fill in the value, for one of the spaces is blank.
Okay. What do you mean fill in the values?
Well, the edit text button would need to have a value of some kind. I would know as long as you're doing your on create the correct way.
Okay. But I'm saying let's assume that onCreate is what it is, right? How could I code this to be more defensive so the program doesn't crash in this case?
Well, it's not going to work in any case if you have a null. You just can't do math on it. So
okay,
it's not kind of a moot thing, yeah.
Maybe I can do better than having the application crash.
Well, you can fill in a default value, I suppose, or just set it right there. Just
okay.
Make,
so let's think about the program as it stands, right? What happens if I don't put in
Yeah, m operand 1 edit text equals whatever the
hey Paul,
your r.id find view by ID at that point.
Hey Paul, let's give somebody else a chance to talk. So what I'm asking here is so what can I do? If we type in, let's say we leave the fields blank, right? What was the behavior there? If I left the fields blank, what was the behavior that we saw with the good working application?
Error message.
It showed an error message, right? So we should probably do that as well, right? Rather than having the application crash, we probably want to show error. So what can I do here, right? What should I do in the catch in this case that will show an error instead?
Print out the error message.
Okay. How? What code?
The code that's in the previous catch.
Okay, that's probably a good start, right? Okay, so if we say that, well, let's think about like what is this first. First of all, there's some problems here. Let's think about the first line of code there, right? That doesn't make a lot of sense. What's it logging? It's logging number format exception, right? Is this a number format exception anymore?
No.
Okay. And so we probably should update that. We should probably say that. Should it say log E? Yeah. So E stands for error, and there's a few different log levels you can find in here. So you've got, if you kind of think about the different logging levels, you go back here, and there's a table. So there's a few different log levels that you can write stuff out at, and there. So we could log things out as error, says that here serious error conditions, warning, unexpected behavior, non-fatal, info, status info such as database connections, debug, all debug logs, verbose, all verbose log statements. So what should we categorize this as? Is it really an error, or is it a different level?
I mean, error says exceptions.
Uh-huh.
And it's a null pointer exception, so it'd be an error.
Okay. What's the very last thing there?
Crashes only.
Crashes only.
So what are we doing here? We're making it not crash, right?
Yeah.
So inherently, to log it at an error, it isn't technically correct, right? So what would be a more appropriate level if we're going to keep the program running?
A warning.
Warning, right. So unexpected behavior, non-fatal issue. So that would actually probably should be a W. So what I'm trying to get there is don't just blindly copy the code because hey, maybe that code has some issues in it already, right? So that should probably be a warning. Is that correct? And what in the world is that doing? Right? Do I need so we see that one's logging. Okay, that's probably a sensible thing to do, so we can see the exception on the terminal and logcat and see what's going on there. But what's this doing? What's it doing in that second line of code?
setting the result
Okay.
to the string that you're
Okay.
wanting to show the user.
So that result text view, that's probably the field. That's probably this text view down here, right? So set that to, what is this? Get string, r string computation 0. Well, we know that r dot string dot this, right? So this is obviously a string resource, right? So r dot string dot computation error tells me that if I want to find out that string, I should be able to go find it in strings.xml, which it's here. Everybody see that? So what it's doing is it's taking that ID, so that ID, which is actually an integer, and it's calling getString. So take the resource ID and get the actual string that represents it. Okay, that makes sense? So they're taking the ID and turning it into the actual string.
I got a question
Yep.
about the log.e, log.w.
Yeah.
Okay, for maybe organizational purposes, we need to label it the right way. Use W or E or D or whatever it needs to be. But how does it appear differently in the logcat? I mean, is it just a different color? Like I see red, blue, and black there. I don't think mine does that. I got the dark theme, but whatever.
So they are different colors, and depending on your theme, they may not be the same color for you. So for instance, me here, this debug is showing up black, my warning showing up blue, my error showing up red. So the thing you don't want to do is pick the letter based on the color. You want to pick the letter based on the severity. But you can see it here. You can see that E/ or the W/. That's where you see it. So it's W/ and then the tag name, or E/ and the tag name, D/ the tag.
Okay, so we don't change based on the color, but it will appear in a different color depending.
Yes, yeah. Typically, it will appear in a different color. That being said, verbose, and a lot of times verbose, I and D are all the same color. So you can see verbose is black, I is black, and debug is also black.
So, yeah, verbose to be log.v.
Huh? .v, yes. Yeah, it's the first letter. It's the first letter. So V is in verbose, yeah.
Yeah, explain that real quick. Verbose, I thought, was kind of like a catch-all. It's the most unabridged version that's out there. Yeah.
So verbose is it's the lowest level. It's the kind of the things you would put at the verbose level are only things that would be useful to the programmer that's actually working on that code. And typically verbose logging should never make it into production. Ever. Like, you should remove it before you release the app. And you should actually remove any verbose logging before you check your code in. So, like, this is actually bad. Like, verbose keyguard update monitor, right? That's not helpful to us, right? Somebody else left that in there, right? So
that's buried. That's buried pretty deep then.
Yeah. So this is yeah. So this is probably the Android operating system. Somebody they had a log message in there that they said, oh, on subscription info change. They're just trying to see that this method was called, but they didn't remove the cut. They didn't remove it when they needed to. So verbose is really only ever going to be helpful to you. And again, so oftentimes people use the letter for verbose to just print out like, hey, this method was called, or here's the value of a thing. So, which is actually what's happening in both of these cases. They logged that this method was called and that the variable subinfo has this value. But those are typically not things you want to keep in your code once you're done. Okay. So verbose is usually something you use as you're testing, and then you remove it later. Debug is then the next kind of step above that, is kind of things that are less descriptive, and they're kind of, as I say, debugging notes. Sometimes you put variable values in there. Both of these are kind of two things. A lot of people make the mistake of putting like secret stuff in there. at least when they're testing, such as passwords and such, but that's obviously not secure. The next kind of level up is info. So info would be about things that are connecting, that are happening in your application. Like you logged in, the user logged in, or they bought something, or they did this or that. It's kind of to track down the sequence of events. And it's generally recommended by the time you deploy your app, the only levels that should be left in a working and deployed app are info, warning, and error. Right? Those are the only 3 levels that a finished application should have.
What does assert mean? That's on the drop down in Android Studio. That's
Okay.
the last thing.
So assert is that highest level. That is not one that you should use. Assert is things like assert is things like where really, really bad. So that means things like I made an assumption. What you can do is you can put assertions into your code, and you're saying here's an assumption that I'm making as a coder. I'm making an assumption that such and such is true, right? So one of those assumptions might be, and let me pull this catch out a minute here so we can see that. So an assertion is as I said, is an assumption. So, but you put it in a code to say this is how it should behave. So I might in here be assuming assert. I need to spell it right. I think. And I gotta remember where those asserts are in Java. Java assert. Yeah, so it's assertions. That's the class I'm interested in. So I might make an assertion. Why is that? That doesn't make sense. That was not the link I wanted to go to. So an assertion. Oh, nope. Not clicking on the thing I wanted to click on. I wanted to go to Oracle. There we go. So where's their line of code? Yeah. Okay, there it is. Assert. Yes. That might be old, but I think that's the one I want. Assert. Yep. Okay. So I might say assert does not equal null. So here I'm making an assumption. I'm saying this, if I get to this line of code, it should never be the case that this variable is null. Does that make sense?
Yeah, it's like an override, if you will.
Yeah, I'm saying if this condition is not upheld, then something is seriously wrong. All right, so I'm going to run the program now, and hopefully, if I played my cards right there, that should trigger an assertion there. Okay.
Don't you want to filter off of assert or at least everything?
Well, here's an interesting thing. So it didn't come out as an assertion even there. It came out as an error, right? So what that means is basically assert. Assert is reserved for the Android operating system itself. So honestly, I've never seen that error fire, but that if that's firing, there's nothing you can do about it, right? That's the worst case scenario. So that would be places where I think you get assertions. I would speculate is probably where you're out of memory. If your system runs out of memory, that would be considered an assertion. It's like, well, I can't solve that. I'm just going to crash. So the way this works is it's a kind of level of severity. So when I'm picking from the drop-down, I'm saying, here's the minimum severity that I want to see. I want to say warnings are worse. So when I picked warning, it actually includes warning, error, and assert. Does that make sense?
Yeah, right. Okay.
So that's why the severities are declared the way that they are, is to say how critical of a problem is it. So in this case, we're just saying, well, the program, according to the documentation, the program didn't really crash, so a warning would be appropriate because we've aborted the issue. Right. So a warning would actually make more sense. Would make more sense here.
Okay, so just by default, we probably want debug. Like, I don't need a notification that my clock's been updated to the next minute.
I would not make that assumption. I would not make assumption of any default. In terms of logging, every case is special. In terms of logging, there is no one size fits all solution. Okay. So
Okay.
you do need to look at your specific case and see what severity is it. I will say that most of the time, if it's in a catch, it should probably be warning or worse. Okay. If it's in a catch, it's probably a warning or an error. Does that make sense?
Yes.
If it's not in a catch, then it's probably debug or info. Probably. But there's not a hard and fast rule there. There are still cases, let's say, maybe you're getting an exception because the user put in the wrong username and password, right? If the catch is catching that user put in the wrong username and password, or it's an exception because they left the field empty, where would that fall? If you're logging that the user put in the wrong username and password, where would that fall? That would probably fall on info. Does that make sense?
Yes.
So if the exception is caused by that, then I would log it at info, which means that your catch could actually be info, and that would be reasonable. Does that make sense? And that's why it's situational, because the level depends on the cause. Okay. So I would probably write that, and if I was going to make this, say error in that case as well, I would probably do those things, right? So log it, write it. If I kind of play around with it there, I can see that I hit add. Okay, it says error. That's fine. We've got the warning coming out marking that happened. Now, it's worth noting, there's this line return. Is that really necessary? What happens if, say, I don't put that return there? Well, if I don't put that return there, my program actually doesn't compile. Now, why does my program not compile in that case? Well, look at what it's complaining about. Operand 1 might not have been initialized. Okay. What is it complaining about? Why might it not have been initialized?
Well, all I know is that every outcome needs to return something, or actually no, and we got a void method here, so
yeah.
I don't know, but I've always thought that all code paths need to return something.
Okay.
That's a finality to it.
Okay. Well, yeah, sort of. At the end of the term, the function needs to return whatever the value is, and so, but the value here is void. So, if it just reaches the end of the program, then it's fine. But that's not really what's relevant here. What we're seeing, right? Why have in this pathway? Why have those not been initialized?
If it throws an exception, then it doesn't assign the two values, so it might not have it.
Correct. Because the assignment's happening up here in the try, right? So that line of code might not have completed. Does that make sense? So in this case, well, what could I do? What could I do that would make that be initialized? Down here. What could I do to make that error go away other than returning? What's another possible solution to that?
Make them 0.
Okay. So make them 0 in the catch, or make them 0 up here? Probably both, right? So I could do either one. I could say, if I say up here, this is equal to 0. All right, let's try that. Well, that's a problem, right? It should have said error, right? So that's part
There we go. You got to do it in the catch block there.
Yeah. So that's kind of, well, because well, what happened there is we kept going and we kept going with the values 0. If I say, well, let's set them here. I still have that. I'm still going to have that same behavior that it goes to 0, because it's running it's goes ahead and adds the two numbers, but it ends up adding the numbers 0 and 0, right? The point there is I don't want to keep going, and that's why the return is kind of there. So the return is to keep it from actually running the calculation. It's the point of that is to keep the rest of the code from running. So anyway, so does that kind of make sense? So you can kind of see where all three of those things are happening there. Logging, setting the message, and returning.
Returning keeps the rest of the code from running. What do you mean by that?
Keeps the rest of the code from running. Well, so return terminates the method, right? Once you say return, that's by definition the method is over.
So every catch block should have a return?
No.
Okay.
No. Not every catch block should have a return. Most of them shouldn't. So that's kind of why those things are there, right? And why those pieces are there. But you saw, so if you have an exception that you don't list, a catch block for, then it crashes the program. So does that answer your question, kind of going back?
Say that last sentence.
So if it didn't have this catch, you saw that it crashes, right? It's not handled, so therefore an unhandled exception is a crash.
Okay. All right. So when in doubt, if there's an error, it's probably a missing return statement that'll conclude the method.
Probably missing return statement.
Try that. Okay. That's okay.
Yeah. So, you said if there's a what? Probably a missing return statement?
If there is a problem down below, for example, with the switch that we're using.
Yes. Yeah.
The problem was that we didn't conclude the compute method because there's no return statement on the catch blocks.
Yeah. The error was telling us, you should probably set is it kind of indicating, if you just read that, would indicate that you just need to set it to 0. But the real problem is that you actually just want to return. So sometimes what you see in the red underline is kind of telling you the problem it sees, but that's not actually necessarily what you need to do. So sometimes your compiler, sometimes your IDE will lead you in the wrong direction there. Okay. So we've kind of seen how to use some of those tools in terms of the debugger, how to kind of look at the values and go around. And so we looked at breakpoints. Let me just see if there's anything. We looked at the frames. We looked at that. Resume, pause. Yeah. So we basically kind of we've used those buttons so you can kind of see how to troll around in. Oh, I meant to keep that open. So any questions about kind of using the debugger? Or is everybody kind of feeling comfortable with that now? Kind of where those buttons are and that kind of thing. Daniel?
Yeah.
Were you chiming in? Okay. Guess not. Just checking to see if I saw anything. So given kind of that, yeah, okay. So that's that. So I think given the time that we have right now, so what I ask you to do is just get started on the labs then, and go start with the sum project.
Okay, so it's basically like lab time the rest of the day.
Yeah. So I just jump into lab time and start working with those then. So
Okay.
You've got the three exercises: some product, prime numbers, money tracker, and So I want you to build those three application as Android apps, and kind of test and debug them. Try to use the debugger tools as you're going through that. Obviously, the problem with the problem with that is like, well, like at the end of the day, it's I can't see whether or not you use the debug tools right in the code you turn in. So all I'm trying to give you is something where you can try to put those tools to use. Okay.
What do you mean you wouldn't be able to see it? If you downloaded the code, wouldn't you just be able to run it and see?
Well, I don't know if you use the debugger to write it, right? I can try and find it and see if there's any bugs you missed, right? But I don't know how you fix the bugs. Does that make sense?
Okay, yeah, all right, I get it.
So the whole lesson today was about how to try and use those tools to fix bugs. But the finished project that you turn into me should be a program with little to no bugs. Ideally, no bugs for these tiny programs. Does that make sense?
Yeah.
So that includes things that we saw here, like so infinity. If it returns, that return infinity, well, I consider that potentially a bug. It doesn't have a limit to the size of the number that I can put in, right? So that would be a bug, right? If it let me put in, if there's an issue there with letters, then that might be an issue. I would mention here real quickly on the reason that it didn't let me put in numbers is if I go to the field, it's because the field is input type is number decimal. That's what prevented us from putting letters in there, is the input type. So if that was just text, then you could have typed in letters. Okay.
All right, so you'll just be around for questions, and we'll just start working away at these and take breaks as needed. Yep, that's it till tomorrow, right?
Yep, that's it till tomorrow, and then tomorrow we'll talk about unit testing.
All right, awesome.
So basically we talk about manual testing today, and we'll talk about automated testing tomorrow.